Yeah,
Now we are
okay.
talking about fatigue and all. So how to define the cycle loading? So to start with, obviously no structure undergoes constant amplitude loading unless it is very specific, like you have a constant RPM of engine and all. Those are constant amplitude load, or your flap deflection, retraction, traction. There will be one duty cycle that will consider a constant amplitude loading. But in general, to understand variable amplitude loading, you have to start with the constant amplitude loading. So it's maybe sine, cosine, and where is defined as stress range, stress amplitude, mean stress, stress ratio, and amplitude ratio. Obviously, amplitude ratio is not being used so extensively, but please remember stress ratio is defined as minimum stress by maximum stress. That is one thing. Second thing is stress ratio and mean stress, they are interrelated. When you talk with R is equal to 0, R is equal to -1, R is equal to greater than 0, that means it reflects the mean stress. That will got to know and subsequently. And this is how you define stress ratio of 0 and stress ratio of 0.1. In testing, you ensure 0 stress where minimum stress is 0, maximum stress whatever value is. And point stress is same 100, but 0.1 stress means it will be 10%. And of course, the people who are worked in Airbus project, they know R is equal to 0.1, right? Why it has been done, I will share you. I'll tell you. Even your fatigue equivalent stress, why it has been generated 0.1, why not any other stress? So there are major three categories of cyclic load. One is called a repeated load, where you have R is equal to 0. Another is fully reversed, is called R equal to -1, where mean stress will be 0. And another is called fluctuating, where R is more than greater than 0. So this all
Sir,
started this fatigue phenomenon.
sorry, excuse me, sir.
Yeah.
Uh, what is the difference between that repeated and fully reversed, sir?
Or you can see the maximum and minimum, they are equal and opposite.
Okay. R -1. Okay.
Yeah. And R is 0 here, is minimum stress is 0. And fluctuating means it can be anything other than R is equal to 0, R is equal to minus. It's not expected to come negative thing.
Okay, so we don't have our negative sides in the repeated. We don't have negative
No, it will
stress.
be
It's
there.
all
It will
positive.
be there. I will tell you on the effect of mean stress. I will tell you. Yeah, it will be there.
Okay.
In the top left graph there, can we assume that it's all like positive tensile loading and no compression? That's why.
Yeah, R is 0 means there's you define R is equal to minimum stress by maximum stress. Right? Minimum stress 0. 0 by something. S max.
Yeah. So if there is a structure which is only in tensile loading.
Yeah. The negative it will have a different. Minimum and maximum.
No.
That will be
Okay.
different. It will come with minus something. -1 means it is positive, negative equally.
That means compression and tension.
Yeah.
Both.
Yes.
Okay.
Okay.
Thanks.
Now coming to the fatigue, this phenomenon started based on when the railway is introduced as a part of the transport. I mean road transport. It will be bogie with wheels running into the railway thing, and it's subject to the cyclic load, and is a fully reversed because the point which is in the top is see this is you can imagine the simple bend simple supported beam. The reaction is here, and load bogie load is acting downward, so the axle will be running complete 360 degrees. So when on the one instant where it is a going compression, but when it rotates to 180 degrees, same point you will see the tension. So it's a fully reversed. So the first to appreciate the catastrophic efforts of stress reversal railway engineers way back 1840s, and broken axles caused countless accidents as railway lines crept across Europe and America. In fact, at that point of time, internet says that every alternate there will be some reported that so and so place some accident happened, some accident happened and all. So being simply a rotating horizontal shaft with heavy vertical load on it, every locomotive axle suffered severe stress reversal in their outer skin with every rotation. Okay, that's understood, right?